for the next part, it's your now you try problems, and in this section you're going to determine whether the given numbers are solutions for the inequalities x less than or equal to 1 or x greater than 2 versus the same inequalities connected by and. Make sure you take some time to try these problems first before you continue the video. Whenever you're done with the problems, go ahead and start the video over here. And in this case, when you are starting the checking process, we're going to do exactly the same as what we did in the example problems. So we're going to go ahead and plug 2 into the variable here. We're checking whether 2 is less than or equal to 1 over here to start with. And because we are given this scenario connected by or, when we check 2 is less than or equal to 1, we can see this is a false statement. But this doesn't automatically mean that 2 is not a solution in general, because we're trying to make sure at least one inequality is true for an or statement. So now if we check the second inequality, we would get 2 is greater than 2, or we want to check whether 2 is greater than 2. And in this case, we know that 2 is equal to 2, so it's not greater than 2 over here. So this is also false based on our definition. We would actually get, because both statements are false, in general 2 is not a solution for our compound inequality. So we would say no, 2 is not a solution to this compound inequality. And similarly, we can check for part B. We are checking 1 as a solution. We are testing whether 1 is less than or equal to 1 or not. In this case, we know 1 is equal to 1. By our understanding, we would know this is a true statement because 1 is equal to itself. And then we want to check whether 1 is greater than 2 over here. And I am checking over here, even though I know this is a true statement, it's just for practice purpose. But if you want to be efficient and see, once you have that true statement, you don't technically have to check the second inequality. You already know that 1 is going to be a solution, because in order for the number to be a solution for inequality connected by or, we just need one of them to be a true statement over here. So already technically, if we know this is true, we can say that yes, 1 is a solution right away to the compound inequality. And just for the purpose of checking both, we can go ahead and see what happens over here, because you would have to do it for the next part anyways. And here, if we check whether 1 is greater than 2, we see this is a false statement over here. Because of that, we'll know that in this case, 1 is going to be a solution because it's connected by or, but when we work on number 2, we'll see right away it's not going to work later on. Now for the last part, for part C, we are checking the number 5, and we would have to check whether 5 is less than or equal to 1. We can see this is not true, so this is false. And this again doesn't automatically mean that we would rule out 5 as a solution in general, because we still have one more chance. And here we would check whether 5 is greater than 2. And we can see indeed 5 is greater than 2. Because we have one solution or one inequality being true, we would say yes, 5 is a solution to the inequality, to this compound inequality over here. So in this case, both 1 and 5 are solutions by our definition. And if you have already tried number 2, we can just continue from here. The checking process for inequalities will give us the same conclusion. So just based on the conclusion for the 2 inequalities in each part. For part A, we see both statements are false. So when we have 2 statements both being false, we know 2 is not a solution over here to our compound inequality. And for part B, we see that one of the statements is true, but in order for it to work for an AND statement, we need both inequalities to be true over here. So because we don't have that, we would say no, one is also not a solution to the compound inequality we have. Lastly, for number 5, same thing as before, we notice that it's given us only one true statement. Because of that, it doesn't work for a compound inequality connected by AND, so we would say 5 is not a solution to our compound inequality over here. And that's the conclusion we get when we're testing compound inequalities connected by AND versus OR over here.